Good evening, ladies and gentlemen, or good morning, or good afternoon, whatever the case may be. Today we're going to look at a brief little video on factoring a 101, the very basics of factoring. This video is going to help you with the next IXL due, which will be IXL Algebra 2 J1, which just talks about factoring. So why do we factor? Why factoring? Why factoring? Why factoring? Well, we need to learn to factor because we need to be able to put things in a factored form so that we can use the zero product property. And we've used the zero product property to solve some quadratics before. For example, we had a quadratic that looked like this: x minus 2 times x plus 3 is equal to 0. And we saw that, and we've done this a lot. And this is factored. I have this factor here, x minus 2 times x plus 3. And that's factored already. Well, I can solve it real quick. I can say, hey, x is equal to 2 or x is equal to negative 3. So the reason why we factor, the reason why we factor is so that we can eventually use the zero product property to solve any type of equation. Alrighty, so a is 0, and that's the zero product property. If I have a factor, if I have a times b is equal to 0, that says a is b or b is 0. Alrighty. So what we're going to do today on this video is we're going to look at two basic concepts. All right, we're going to look at two basic concepts. The rule number one is the product rule for like bases. So if I have like bases, if I have a to the n times a to the m, that's going to equal a to the n plus m. We've seen this. This is the product rule for like bases, exponent rule number one. This is an exponent rule. And we're going to use that a lot, and we're going to use that a lot today. Good example of that. Do I have time? Here's a good example of that. Well, w to the fourth power times w to the fifth power. That's equal w to the 4 plus 5 is ninth power. So we're going to use this property a to the n times a to the m is equal to a to the n plus m a lot. We can use that today. That's the basic product rule for like bases for exponents. The other thing that we're going to use that you've used a lot in algebra that most people know about is this guy right here. I have something factored here. Here I have a factor, a times a factor b plus c. What does that equal? That's equal to a times b plus a times c. And we all know that to be the distributive property. Okay, that's the distributive property because you take what does the distributive property do? It multiplies a number to a sum of numbers. So I have a times the sum of numbers, which is a times b plus a times c. What we're going to look at today is we're going to look at some sums that look like this, and we're going to use the reverse distributive property because right now this is not factored. This is a sum. What we're going to do is factor and make it into a product. And we're going to factor out here, we would factor out the a. How are we going to use that? We're going to use the distributive property. So these are the two basic rules that I'm going to use today. The basic rule for like bases using the exponents and the distributive property. So let's jump in to a couple examples here. Example number one, I want to factor all of these. I have three examples here. And what I'm going to do, I notice that this is a sum. What I always want to do is I want to factor out the greatest common factor. The greatest common factor. That's what we want to factor out always, is the greatest common factor. So I'm going to look at both of these terms. Here I have two things, two add-ins. I'm going to look at this guy and this guy, and I'm going to factor out the greatest common factor. Well, this is a sum. whatever I do, and this is a nice method to do that, well, hey, both of these terms have a factor of 2 because this is 2 times a to the 7th, 4 times a cubed. I can pull a 2 out. And this is a to the 7th, this is a to the cube. Looks like both of these terms have an a cubed, so the greatest common factor is going to be 2a cubed. Now I'm going to ask myself a question. 2a cubed times what is 2a to the 7th? And now I have to use that like basis. Well, 2 times 2 is 1. I know it's going to be 1 here. But it's going to be 1 times a to what? Well, I have to ask myself a question. 3 plus what is 7? Well, 3 plus 4 is 7. So now I have 2a cubed times 2a to the 4th is a to the 7th. 2 times 1 is 2. And if I factor out a 2a cubed here, what do I have left? I simply have a 2. Oh, a 2, because 2a cubed times 2 is 4a cubed. So the factorization, to write it nice and clean, is simply going to be 2a cubed times a to the 4th plus 2. Okay, example number 1. Example number 2. Here I want to factor out the greatest common factor again. You always want to factor out the greatest common factor. So there's 2 terms here. What I'm going to do is I'm going to use the reverse distributive property here. Let's separate this example 2 from example 3. And I notice that each term here has a 7. I'm going to factor the 7 now. And each term has the minimum of a y. And so now I'm just going to ask myself, that's the greatest common factor of these 2 terms, 7y to the 4th and 21y. I ask myself a question, 7y times what is 7y to the 4th? And I can see that that is 7y cubed. Y to the 1 times y cubed is y to the 4th. 7 times 1, the 1 is implied, is 7. And now I ask myself a question, 7y times what is 21y? And we know that that is 3. So let's do another example here. We have 15w to the 10 plus 20w cubed. There's 2 terms, so right away I'm going to write parentheses down below that. And I want to factor out the greatest common factor. You're going to get the hang of this pretty easy. This factoring out greatest common factors is much easier than factoring quadratics. And you'll get the hang of that. So now I want the great, I'm looking at 15 and 20. What's a common factor between those 2 terms? The greatest common factor, I believe it's going to be a 5. And then w, both of these terms here are w cubed, so I think this is going to be the greatest common factor. And so now I simply ask myself a question. 5w cubed times what is 15w10? 5 times 3, w to the 7. 5 times 3 is 15. W cubed times w7 is w10. 5 times what is 20? It's going to be 4. W cubed times 1 is w cubed. So this is the factorization. Let's get a little bit wild and crazy. All right, on this next example here. Let's go a 2xy squared plus 4x squared y squared minus 8, oh heavens, x, y. So now I have 3 terms here, and each term has 2 variables. Don't get freaked out. Step number 1, don't get freaked out. I have 3 terms, and I want to factor the greatest common factor. Keep in mind, we're always going to factor out the greatest common factor. Let me put this back on the screen. The greatest common factor. That's what GCF is, the greatest common factor. Okie dokie. So what do I got? Well, I have 3 terms, so I'm immediately going to write my parentheses because I'm going to do the reverse distributed. I'm going to put the plus here because there's a plus here. I'm going to put a minus here. And the first thing I'm going to see is the greatest common numerical factor, the greatest common real number factor. And it looks like all of those have a 2. So I'm going to factor 2 out. And then they all have, each one of them have an x, and what x to what power? X to the 1 power. And they each have a y, and the greatest common y is going to be a y to the 1. And now I ask myself a question. 2xy times what is 2xy squared? Oh, heavens. Oh, simply a y. Because 2x times 1 is 2x, and y times y is y squared. And what goes here? So I ask myself a question. 2xy times what is 4x squared y squared? I believe that's going to be 2. Don't write it in yellow, Lee. 2xy. 2 times 2 is 4. X times x is x squared. Y times y is y squared. What's the third term in my factorization? Third term in the parentheses. Well, 2 times what is 8? It's going to be 4. Oh, it's just going to be 4 because 2xy times 4 is 8xy. So this is the factorization of that guy right there. Let's do another one of these crazy, wild, and crazy guys. Okay. Let's go 6 a squared b cubed plus 9 a b to the 4th minus 12 a cubed b squared. Oh, looks kind of complicated, but I think we can do it. The first thing we need to realize is there's 3 terms in my sum. There's 3 terms, so I'm going to use 3 parentheses. I'm going to use a parentheses. There's going to be 3 terms inside the parentheses. Always, this is going to be a plus here. This is going to be a minus here. And so now I'm looking at what's common to each term here. What's common there, what's common there, and what's common there. Well, I say numerically, 6 is 2 times 3, 9 is 3 times 3, 12 is 3 times 4. So it looks numerically that I'm going to have a 3 that's common, and I think it's the greatest one. Oh, well, 6 is a factor of 12, but 6 is not a factor of 9. So we're not going to use 6, we're going to use 3. And now I know each term here has an A, so we're going to put an A here. But we need to figure out what's the greatest power of A that you see? Well, that's A squared, A, and A cubed. What's the greatest that I can factor out is going to just be A to the 1. Because that's all that one has is A to the 1. They all have a B. Happened to mine. And now I want to find the highest B that is common to all 3 terms. Boom, boom, boom. Well, this is a B cubed. That's nice. Oh, and this has a B cubed, but oh, this only has a B squared. So B squared is going to be my greatest common B. And so now I simply ask myself a question. 3ab squared times what is 6a squared b cubed? Looks like it's going to be 2ab. 3 times 2 is 6. A times a is a squared. B squared times b is b cubed. Ask myself a question. 3 times what is 9? 3. A times what is a? 1. Don't write it. I mean, you could if you want to, but you don't need it. It's a 1. It's an implied 1. Ask myself a question. B squared times what is b to the 4th? B squared. B squared times b squared is b to the 4th. Ask yourself a question. 3 times what is negative 12? 4. A times what is a cubed? A squared. And b squared times what is b squared? Just a 1. And so now we're going to rewrite this. We're going to clean it up a little bit. And all I'm going to do is not write the implied 1s. This is 2ab plus 3b squared minus 4a squared. All right, one more crazy wild example. Here we go. You can always pause the video if you need to. One more crazy example. Get this guy out of there. Oh, you mean another term? Yes, we're going to have another term there, dog. All right. So, oh my. Let's see here. There's 4 terms in my sum. First thing you do is easy enough. You write a parentheses. You do the, if it's going to be subtraction or addition, looks like all of these are subtraction symbols. You look at the numbers. Okay. Bam. Whoop, 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 whoop. What's common to all of those numerically? I think it's going to be a 6. I think it is. They all are going to have an S, and they all are going to have a T. Now, what I'm really going to do is just look for the S of the least power, because all of them will have an S to that least power. And looks like the least power is squared. I look for the T to the least power. Oh, looks like it's T to the 5th. And now I ask myself a question. 6x s squared T to the 5th times what is 6? Boy, I can't say that. Say that 5 times really fast. 6s to the 6t to the 8th. Well, it's going to be 1. I know that. Let's write this in, I don't know. Let's write it in green. So s squared times what is s to the 6th, x to the 4th. T to the 5th times what is t to the 8th? T cubed. 6 times what is negative 6? 1. S squared times s to the 5th, s cubed. T to the 5th times t to the 9th, t to the 4th. 6 times, 7. 6 times 7 is 42. Hello. S squared times what is s cubed? S. T to the 5th times what is t to the t? And 6 times what? Oh, 1 times 1. Oh, look. 6s squared t to the 5th times 1 times 1 times 1, which is 1, is equal to 6t. That's why you want to make sure that you do the parentheses. Otherwise, you're going to lose this 1 here. And we're going to clean this up. This is going to be 6s squared t to the 5th, s to the 4th, t cubed, minus s cubed t to the 4th, minus 7st minus 1. Don't forget that 1. Ladies and gentlemen, you've had some good. This is going to take care of IXL J1, and you should be good to go. Happy New Year to you.